Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 17 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3202. Find the maximum length of valid subsequence 2. So let's read the problem statement. You are given an integer array nums and a positive integer k. A subsequence of nums with length x is called valid if it satisfies this condition: sub of 0, sub of 1. Okay, if we add this and do the modulo with k, this value should be equal to sub 1 plus sub 2 modulo with k, and sub x minus 2 plus sub x minus 1 modulo k. Okay, so we have to return the length of the longest valid subsequence of nums. All right, so let's understand this line with this example 1. Okay, so this is your nums array, right? 1 2 3 4 5. Okay, and k value is 2, right? Okay, so here if I do this is at 0 index, 1 index, 2 index, 3 index, 4 index. So if I do 1 plus 2 modulo with k, so what is the value that I'm going to get? Okay, k value is 2, right? So 1 plus 2, that is nothing but 3. 3 modulo 2 is nothing but 1. Okay, right? Okay, so 1 and 2 done. All right, now next time if I pick 2 and 3, so 2 plus 3 modulo with k value is nothing but 2. Okay, so 5 modulo 2, I will get again 1, right? Then if I pick this 3 and 4, right? So 3 and 4, and if I do the modulo with k, so again 7 modulo 2, I will get 1, right? And same way 4 and 5 if I pick, so I will get 4 plus 5, that is 9. 9 modulo with k value is nothing but 2, so 9 modulo 2 is nothing but 1. Okay, so see here let's suppose a value, a plus b modulo k is equal to b plus c modulo k is equal to c plus d modulo k, d plus e modulo k, right? All are matching, right? So this is nothing but a valid subsequence, right? Because here see 1 2 3 4 all are matching, right? A b, right? Then b c, then c d, then my d e, all are matching. Okay, and what is the length of this? Length of this is nothing but 5. So this is what we need to return. The longest valid subsequence is this. That's it. Okay, so I hope that you guys are clear with this statement. Okay, what we need to do, right? So here see this example number 2. So here if you choose this 1 4 1 4, so you are going to get that. Okay, so 1 plus 4 5, 5 modulo 3 2, 4 plus 1 is nothing but 5. 5 modulo 3 is nothing but 2, and here 1 plus 4 5. 5 modulo 3 is nothing but 2. Okay, and the length of this one is nothing but 4. Okay, so 4 is our output. All right, so now here if you see this line, okay, it is saying let's suppose this let's suppose a b and c is a valid subsequence. Okay, so if it is a valid subsequence, then I can say that a plus b modulo k value, okay, modulo k value, it should be equal to b plus c modulo k, right? Okay, if abc is a valid subsequence, right? Okay, now from here I can say one more thing. Here see b is common, right? B is common factor, a plus b. Okay, b is common factor. Here also I'm adding b in the c, right? So b is common factor. Okay, so I can cancel out this, right? So I can say that my a modulo k, okay, this is going to be equal to my c modulo k, right? So here if you see 1 1 modulo 3, 1 modulo 3 is nothing but 1. Okay, 4 modulo 3, 4 modulo 3. Okay, just take this number 4 modulo 3 is also 1. 1 modulo 3 is also 1. 4 modulo 3 is also 1. Okay, so here see all are 1, all are 1, all are same. Okay, but here if you do same thing, 1 modulo 2 is nothing but 1. Okay, 2 modulo 2 is nothing but 0. 3 modulo 1 is nothing but 1. 4 modulo 2 is nothing but 0. 5 modulo 2 is nothing but 1. Okay, so if you notice this pattern, okay, so here let's suppose this is r1, this is r2, then here same r1. Okay, okay, r1 is coming back, then r2. Okay, so again r1. So see this pattern. So here a b c. Okay, so this a value, okay, if I do the modulo of a with 2k, okay, and c modulo with k, I am getting same value, right? So that's what I derived here. A modulo k is equal to c modulo k, right, in this valid subsequence. So I hope that you guys are clear. Okay, so you can simply okay, instead of abc, just take this a b c d e. So from here you can conclude, right? Just take this section now. So a plus b modulo k, it should be equal to b plus c modulo k. We already know this, that this is why it's valid subsequence, right? From here b is common, so I can cancel out each other. Okay, so from this I derived this a modulo k is equal to c modulo k. Okay, so now a modulo k remainder and c modulo k remainder both are same. Okay, right? If I'm taking the mode, so see, both are same, right? Okay, clear? So here you notice one pattern. Okay, so here your mode values, okay, remainders like this, r1 r2, and then there is reverse. Okay, then again we are getting r1, okay, then r2, then here see r2 is coming back here, right? So every alternate position we have, right? So from here, and in this example, if you see, uh, everywhere we are getting 1 1. Okay, so this is r1, this is also r1, let's say r1 and r1. Okay, and here r1 r2 r1 r2 r1. Okay, like this. So we have derived total two type of scenarios. One is this r1 r2, then repeat. Okay, so prev, you can say this is prev, then cur. Okay, then again prev is coming. Okay, then again cur is coming, then again prev is coming. Okay, this is one valid. Okay, or we can say all are same. Okay, oh, everything is same, r1 r1 r1. Okay, so these are the two possible scenarios, right? We have to check these two only. Okay, right? Okay, so this is done. Okay, so now let's understand this example number one. Okay, how we are going to solve this. Okay, and before that, here k is equal to 2, right? So if I divide this 1 with 2, what is the remainder I'm going to get? I'm going to get my remainder as 1. Okay, 1 is one possibility, right? And if I divide 2 with 2, I will get remainder as 0. Okay, and if I divide 3 with 2, I will get 1. Okay, if I divide 4 with 2, I will get 0, right? Remainder. If I divide 5 with 2, I will get 1. Okay, so for k is equal to 2, we have only these possibilities, 0 and 1. Okay, right? Same way, if you see this k is equal to 3, so take any number, 1 2 3 4. Okay, so if you divide 1 with 3, what is the remainder you are going to get? 1 with 3, you are going to get 1 only. If you divide 2 with 3, you are going to get 2 as a remainder. If you divide 3 with 3, you are going to get 0. If you divide 4 with 3, you are going to get 1 as a remainder. If you divide 5 by 3, you are going to get a 2 as a remainder. If you divide 6 with 3, you are going to get 0 as a remainder. So for 3, you are getting remainders from 0 to here. Okay, 0 to k minus 1. Okay, 0 1 2, right? So here also 0 1. Okay, so starting from 0 until k minus 1, you are going to get the remainders. Okay, so that simply means that for all these values, uh, if I want to see this r1 r2, okay, I want to drive this pattern. So there is only this possibility na, that in this case there is only one possibility. 1 is 0, next is 1, 1 is 0, next is 1. Okay, this is one possibility, or this is one possibility, 1 0 1 0 1 0 1 0, or this is one possibility, 1 1 1 1, or 0 0 0. Okay, these are the possibilities, right? Okay, because we have 0 and 1 only, okay, in the search. Okay, so we have to only check these, right? So here if you see this example number 2, k is equal to 3. So here you have 0 1 and 2. Okay, so 0 1 2 means if one scenario is that all are 0 0 0, one scenario is all are 1 1 1 1, all are 2 2 2 2. Okay, this is one scenario. Okay, in this case, okay, all are same. For this you have scenarios like this. Let's suppose 1 is 0, then next is 1, then next is 0. Okay, this is one scenario. Then let's suppose 1 is 0, then next is 2, next this is 0. Okay, one scenario is like this, 1 0 and 1. Okay, then there is will be repeat, right? r1 r2 r1 r2. Okay, this will be repeat. Or you can say 1 2 1. Okay, this is one scenario. Or you can say you may have this scenario 2 0 1 2 or 2 0 2 or 2 1 2. Okay, this will be repeat na, 0 1 1 0. Okay, like this, 0 2 2. Okay, like this, 1 0 1 0 1. Okay, like this. 2 1 like this, 2 0 2 0 2 like this, 2 1 2 1 2 like this. Okay, so these are some scenarios, right? I'm not sure whether I'm missing anything here, but I think that's all. Okay, these are we already covered. All are 0. Okay, all are 1, all are 2, we have already covered. Okay, so is there anything left? 2 1. Okay, I don't think, but yeah, so these are the possibilities. Okay, so these are the only remainders that we need to check. Okay, only possibilities we need to check. So from here I can conclude that I can simply use one DP now. So here every alternate value is going to be same. Okay, so if I know this, okay, and in this I am adding this, okay, so this is going to be one valid. Okay, so the length will be increased, right? Okay, so let's understand how I'm going to solve this problem. Okay, so let's first see this example number 1. Okay, ignore this, let's see this example number 1, how I'm going to solve it. Okay, so see, this is my nums array, right? 1 2 3 4 5, and k value is 2. Okay, so here k is equal to 2, right? So you already know that if I have numbers like this 1 2 3 4. Okay, so if I modulo with 2, I will get here 1, I will get 0, I will get 1, and I will get 0. Okay, so until k minus 1, right? 0 to k minus 1, until there only, right? So we have remainders like this. Okay, so if I divide this 1, okay, or 2 3 4 5, so we can get only values from 0 to k minus 1, right? So here if you see this pattern, so we have like this, right? R1 R2 R1 R2, or everything is same, right? So here for this case equal to 2, I can say that we may have this 0 1 0 1, okay, or 1 0 1 0, or I can say 0 0 0 0, okay, or I can say 1 1 0 0, right? So I can simply create one DP, right? Simply I can create one DP. Okay, so these are the repeated patterns, right? Here 0 1, again 0 1 1 0, again 1 0 0 0 0 0 1 1. So here it will be again 1 1, right? Repetitive, everything is repetitive, right, in these patterns, right? Okay, so here I can create one simple DP, right? So 0 0, how many times I have seen this pattern 0 0 in the start? 0 times. 0 1, how many times I have seen it? 0 times. 1 0, how many times? 0 in the starting. Okay, 1 1, how many times I have seen? 0 0 1 0 times, right? 1 1. Okay, initially this is a setup, right? So let's say this is i's values, right? I 0 I 1, here let's say j 0 j 1. Okay, so now here you have to start from here. Okay, you have to iterate from here, right? So we have to process this array. Modulo is equal to 2. Okay, so at index is equal to 0, number is 1. Okay, and current mode is 1. Okay, current mode, okay, I'm talking about current mode, right? So here cm, current mode. Okay, current mode is I'm getting 1 modulo k modulo 2. 1 modulo 2 is nothing but 1, right? So current is 1. Okay, right, current is 1. Okay, now see this, current is 1, current is 1. Okay, now this its previous it can be 0, it can be 1. Okay, right, it can be 0, it can be 1. All right, so now mark this 0, okay, 1. Okay, so these two sequences. Now here these two are the sequence now. So here I already told you that we have r1 r2 r1 r2 like this. Okay, so here before that, let's say I write here 1. Okay, same way copy this one and paste it here. Okay, let's say, right? So here this is nothing but this is pattern like this, 1 0 1 0 1 0 1 0. Okay, like this is the pattern, right? So and this is the pattern, nothing but 1 1 1 1 1 like this. Okay, right? Okay, so here what I'm doing, 0 1. Okay, so here I'm writing current modulo, previous can be 0 or 1. Okay, and before that I'm just copying this. Okay, copying this back. Okay, so every third we have to write, right? Okay, we already know why I'm doing this, r1 r2 r1 r2. Okay, just think about that. Okay, so now here I am talking, okay, I'm talking about this pattern. Okay, this pattern. Okay, 0 1 or 1 1. Okay, so now for this 0 1 I have to check now how many times I have seen this 1 0 in the past. Okay, this pattern, how many times I have seen this 1 0 in the past, right? And for this 1 1 I have to check how many times I have seen this 1 1 in the past. Okay, so here this is nothing but prev cur, and this is nothing but your cur prev. Okay, same here, p c c p. Okay, so how many times you have seen this 1 0 in the past? So 1 0 pattern you haven't seen yet, right? Okay, so in this you are going to add 1. Okay, because the one, because you are using this, okay, so it's a length, okay, just one, okay, just one number is coming into picture right now, okay, so you are going to add one, okay. So dp01 01, and how many times you have seen 10 in the past? 10 you have seen 0 times, okay, 01. So now this current ending at this current, okay, so you have to add one, okay, so at 01 you are going to operate one, okay, 01, so you are going to operate one here, okay, right. Same way here, 1 1 you are going to update it as 1 only, right. This is done, okay, this is done. So right now max length is going to be 1, okay. So here, if you see, just 1, okay, and just 1, okay, this is the only where it's a value until now, okay, ending at this position, okay, done. So side by side we have to keep track of the max value. So max value until now is 1 only in just dp array, okay, and you already know that why we are right getting 0 1, okay, only checking these things, right. Okay, so we have to create the dp array from 0 to k minus 1, okay, that size. So 0 k size you can say, okay, because 0 is there, right. So this is done. Then after that we are going to process this, okay. So 2 modulo 2, 2 modulo 2 is 0, okay, 2 modulo 2 is 0, okay. So current is 0 0, okay. So before that you can get only two values, right. You can get here 0 or you can get 1, okay. So now you are, this is your nothing but uh, current, and this is nothing but prev, okay, this can be prev, okay. So now after that, here I just I'm just going to put this 0 here, and I'm just going to put this 0 here, okay. So now here I'm saying, to update this, okay, I'm seeing this pattern, so I'm going to check how many times I have seen this previously, okay. Now I'm checking this pattern, so for this pattern I have to check how many times I have seen this in the past, okay. So here dp00 is nothing but dp00 I have seen 0 times, so in this I'm going to add 1, so I will get 1 here, okay, I will get 1, right. So same way dp10, okay, 10 for 10 I have to check this 0 1, okay. So 0 1 how many times? So 0 and 1 I have seen one time, so again I'm seeing, so 1 plus 1, again here I'm going to update it, sorry, not this, dp10, okay, dp10, okay, 10. So here I'm going to update it as 2, okay. Why 2? dp01 01 how many times I have seen? 0 and 1, so I have seen one time, okay. So in this I'm adding, so but why I'm getting two length here? So that is because of this 1 and 2, okay, 1 and 2, and here why I'm getting just one length, okay. So that is nothing but because of this 2, okay, because this is even, okay, even only one, okay. So this both are 1 2 number, both are having modulo has like this pattern, okay. I am following this pattern here, 1 0, okay. Here I am following 0, here this one only, okay, right. So until 2 I'm checking here, okay. So this is done. Now same way here you have to process the index 2, number is equal to 3, current mode is 1. So current mode is 1 1, so previous can be 0 or 1, okay. So for this 0 1 you have to just pick this one, put it here, just pick this one, put it here. So how many times you have seen 1 0 in the past, okay. In this way you are going to operate 0 1, okay, you are going to get this. So how many times 1 1? So how many times you have seen this in the past? 1 1 and this, okay. So your dp matrix after processing number 3, same way you have to in at index 3 number 4 you have to process, okay, and at index 4 number 5, okay, this is what you have to process. In the end your dp matrix is going to look like this, okay. So just follow the same thing that I have explained, okay. So you will get the max value as 5, okay, and this is your output, okay, done, right. That's it, okay. Okay, same thing you have to do for this example number 2, okay. So this is your nums array k is equal to 3, you are going to process this array modulo k. So modulo is k, so for 3 we have 0 1 2, okay, these are the values. So you have to create the dp of like this, okay, of 3 length, 0 1 2 here, 0 1 2, okay, like this. So at index 0 number is equal to 1, current mode is 1. So here uh, current mode is 1, okay. So previous can be 0, previous can be 1, or previous can be 2, okay. So for this pattern you have to find 1 1 2 1, okay. So just put this one behind, just put this one behind, just put this one behind, okay. So here 1 0 1 1 1 2, okay. How many this is the only possible now, right. Okay, r1 r2 r1, here r1 r1 r1, here r1 r2 r1, okay, like this. So that's the reason, okay. So just go over this, okay. I think it's very clear, right. Okay, so just go over all this, right. Try to solve it by your own first, okay. try to make this, okay, try to make us like this, okay, try to make the nodes like this, right? Try to solve it and see whether you are able to form this DP, okay. Then only after that try to write the code, okay. So code is going to be very simple, only few lines, right? Nothing complex, just you need to know this, okay. This is important, this r1 r2 r1 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 r1, okay, like this is important. All right, so now let's write the code. Okay, so first thing that we need to do here is to create the DP. Okay, so DP I of j is going to represent the length of the longest valid subsequence. Okay, so here int DP is equal to new int, and here inside this you have to just pass k. Okay, so you already know that why we are passing, okay, 0 to k minus 1. Okay, so k is going to be the length, all right, for rows and columns in your DP. Okay, and here create one variable result and just set it to 0, and then you have to just iterate over all the values in nums. Okay, so int num, you can use simple for each loop nums. All right, and here you have to check the current mode. Okay, so same story that I explained, current mode is equal to num modulus with k. Okay, done. And then you have to check for all the possibilities, right? So for k is equal to 2, you have possibilities like 0 and 1. Okay, so int here preb mode, let's say preb mode, and initialize it with 0, and here preb mode value, okay, it should be less than k, and here preb mode plus plus. Okay, done. Now inside this, what you need to do, we have to update the DP preb mode current mode by extending the sequence ending in current mode preb mode. Okay, so here DP, so here whatever you are doing, right, you are writing here preb mode, right, and here you are writing cur mode. Okay, you are going to update this. Okay, so before that you need to check whether have you seen this pattern, okay, where cur mode is going to come and then prem mode is going to come. Okay, so this in this you have to add one, okay, because you are adding the current number. Okay, all right, so in the result we have to update. Okay, so result is nothing but math dot max of result and this value, that's it, and paste it. Okay, done, that's it. Okay, and in the end just simply return the result, return result. Okay, now let's run the code and see if the code issue will try to fix that. So yes, there are some issues, so let's fix them. So here DP prev mode, and here current mode I'm writing. Okay, let's use current mode only then. Okay, let's run it again. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.